हेलो बच्चों, हम लोग अल्कोहल, फिनॉल और ईथर चैप्टर के अंदर लास्ट लेक्चर के अंदर अल्कोहल के रिएक्शंस की बात कर रहे थे। तो उसके अंदर हम लोग रिएक्शन ऑफ अल्कोहल्स विद फॉस्फोरस ट्राइक्लोराइड, फॉस्फोरस पेंटाक्लोराइड, थायोनाइल क्लोराइड और आयोडीन, इन चार रिएक्शंस को देखने वाले हैं। तो पहला इज रिएक्शन विद, ये रिएक्शंस आप लोगों ने 10th चैप्टर के अंदर ऑलरेडी स्टडी कर ली है, बट फिर भी एक बार फटाफट से रिवीजन कर लेते हैं। रिएक्शन विद PCl5, तो व्हेन अल्कोहल रिएक्ट्स विद PCl5, देखो बच्चों ये मेथड आप लोगों ने सीखी है। इसके अंदर क्या होने वाला है, तो PCl3, ये जो 5 क्लोरीन एटम्स हैं वो आपके 3, 2 और 2 में डिवाइड हो जाएंगे। दैट इज PCl3, Cl और Cl। एक क्लोरीन जो है वो यहाँ पर OH की जगह पे आ जाएगा, ठीक है, OH की जगह पे। तो क्या बनाएगा आपका वो RCl, दैट इज हेलो अल्केन बनाएगा। यहाँ पर एक क्लोरीन जो है वो आपका इस हाइड्रोजन के साथ कंबाइन हो जाएगा और बनाएगा HCl। ये आपने ऑलरेडी पढ़ा हुआ है। बचा क्या अभी, PCl3 और ऑक्सीजन, दैट इज फॉस्फोरस ऑक्सीक्लोराइड, POCl3 बन जाएगा। एक आध एग्जांपल ले लेते हैं। तो एग्जांपल में आप मीथेनॉल ले लीजिए प्लस PCl5, तो मीथेनॉल का PCl5 के साथ रिएक्शन कराओ। जैसा कि हमने पढ़ा कि इसके 3 पार्ट हो जाएंगे, PCl3, Cl और Cl। ये Cl ये H के साथ कंबाइन होकर सबसे पहले बनाएगा HCl। उसके बाद PCl3 इस ऑक्सीजन के साथ कंबाइन होकर बनाएगा POCl3। देन आपका क्या बचा, CH3 और Cl एक दूसरे के साथ कंबाइन होके बना देंगे क्लोरोमीथेन, ठीक है। चलिए, ये बात हो गई रिएक्शन विद PCl5 की। अब हम बात करते हैं रिएक्शन विद PCl3 की। रिएक्शन विद PCl3, अच्छा उसके पहले इसकी नोट्स लिख दो PCl5 की, बराबर, क्योंकि रिएक्शन लिखने के बाद आपको स्टेटमेंट्स भी लिखने होंगे। नोट्स में क्या लिखोगे, तो अल्कोहल्स reacts with PCl5, that is phosphorus pentachloride, to form haloalkanes and side products. Here the haloalkane form depends upon the alcohol, that is if you are taking primary alcohol you will get the primary haloalkane, if you are taking secondary you will get the secondary haloalkane. Here the haloalkane formed depends upon the nature of alcohols, क्योंकि अल्कोहल्स हमें वैरायटी में मिलते हैं ना, प्राइमरी, सेकेंडरी, टर्शियरी, इसीलिए इस मेथड को अच्छे खासे एक्सटेंट पे यूज किया जाता है। अब जो सेकेंड पार्ट है दैट इज रिएक्शन विद PCl3, चलिए उसको भी समझ लेते हैं। Phosphorus trichloride reaction with PCl3, phosphorus trichloride. So what we will do, we will react alcohols with PCl3. So what will happen? So here one thing is clear, that you will form the RCl. Here you will require 3 alcohols, so here 3 haloalkanes will form. Now what we are left with, we have got one phosphorus atom, and we have got 3 hydroxyl group. So we can say that POH thrice or phosphorus acid H3PO3 will be forming. Clear है? चलिए, let us take the examples. So for examples, the first is methanol will react with phosphorus trichloride. 3 moles of methanol will react with 1 mole of phosphorus trichloride, and it will form 3 moles of methyl chloride. Then what we are left with? We are left with POH thrice, or basically can we say H3PO3, phosphorus acid. If you want to take second example, you can take ethanol over here. So this ethanol, when reacts with PCl3, what it will form? CH3CH2 and 3Cl will combine, and this will form ethyl chloride like this, and these 3 OH groups will combine with 1 phosphorus and will form POH thrice, or you can write H3PO3 over here. Done? Though that was the reaction with PCl3 and PCl5. Let us see the reaction with SOCl2 now. Statement you obviously can write that alcohols when react with PCl3 and will form the haloalkanes and side product phosphorus acid. The third method is reaction with SOCl2. This reaction of thionyl fluoride with alcohol is the best method for preparation of haloalkanes that already you have studied. Okay? So what will happen? The alcohol's general formula ROH will react with SOCl2. This will get converted into 3 parts, SO, Cl and Cl. So 1 part Cl will combine with this H and will form HCl. 1 part of SO and 1 part of O will combine to form SO2. Now 1 part of R and 1 part of Cl will combine to form haloalkane. This method will be the best method for preparation of haloalkane. Why? Because the side products formed are gaseous in nature, so they can easily be separated from the rest of the reaction mixture. Let us take the examples. The first example is methanol. When you react methanol with thionyl chloride, what will form? CH3 and 1 Cl will combine to form CH3Cl, chloromethane. 1H and 1 Cl will combine to form hydrochloric acid, HCl, which is obviously a gas. And this SO and this O will combine to form SO2 gas. SO2 gas. So this can be the chloromethane. Chloromethane, again a haloalkane. Okay? This is your alcohols. You are supposed to write at least the name of the reactants and the products. So what we'll write in the notes? When alcohol reacts with SOCl2, that is thionyl chloride, it forms chloromethane. Sorry, it will form, general say, haloalkane and side products. This method is the best method for preparation of haloalkanes. For preparation of haloalkanes, because the side products are gas. The side products are gaseous in nature and can easily be separated. Gaseous in nature, so they can easily be separated from the reaction mixture. Now let us see the reaction of iodine iodine with alcohols. So you are knowing that reaction of iodine with alcohol will form the iodoalkane and the phosphorus acid. Let us see. The fourth and the last method is reaction with iodine. Reaction with iodine. So what will happen? Alcohols will react with iodine in the presence of red phosphorus. This will form the alkyl iodide Ri plus. You will be forming H3PO3. You will be forming H3PO3. Okay. So alkyl iodide and H3PO3 will be the side product over here. So what we can say for examples? The first, methanol reacts with iodine in the presence of red phosphorus. What will form? So it will form methyl iodide plus H3PO3. It will form methyl iodide plus H3PO3. Is it done? Okay? Chalo. Iodine equation you always can balance. Okay? Organic chemistry it is not necessary to balance the equation, but still if you want you can already always balance that you are knowing now. Okay? Okay. So what we can write for the notes? Alcohols reacts with iodine in presence of red phosphorus to form iodoalkanes and side products. Iodoalkanes and side products. Okay. So this was all about your reaction with PCl3, PCl5 and SOCl2 and I2. Now coming to the very important topic of this chapter, which is known as dehydration of alcohols. Dehydration of alcohols. So students, what do you mean by dehydration? So dehydration basically means removal of water. What do you mean by dehydration? So basically dehydration means removal of water. So in this case, that is dehydration of alcohols, you will be removing the water. Remember, in this reaction the predominant role will be played by the temperature of the reaction. The alcohols will form different products at one temperature and yet another product at some different temperature. Let us see. So first, let us say that reaction temperature is 440 kelvins. 440 kelvins. So in the first case, what you are doing is taking the reaction temperature at 440 kelvins. So what will happen? Let us say we are taking methanol. So methanol, when reacted with concentrated sulfuric acid at what temperature? So at 440 Kelvin temperature, what will happen? So here you can see that this carbon is alpha because it is directly linked with OH group. So alpha carbon ka OH group and beta carbon ka one hydrogen atom will get de-eliminated and it will remove H2O. Basically it is beta elimination. So here what we are left with, here one hydrogen is removed, here one OH group is removed. So here you can see that the valency of the carbon is not balanced. So for balancing, we will have to put the double bond, and hence we can say that alkene is formed. So when alcohol reacts with concentrated sulfuric acid at 440 Kelvin temperature, it will form alkene. So we can write K alcohols when heated with concentrated H2SO4 at 440 Kelvin. Remember the temperature. With concentrated H2SO4 at 440 Kelvin, they lose the water molecule. And alkene is formed. The reaction is basically beta elimination. The reaction is basically what, bachcho? Beta elimination. So let us see the mechanism part. Before we go for the mechanism, let us take the screenshot. Mechanism is very important. This question is very important. It is asked along with the mechanism only. Let us see the mechanism. So, what do we mean by mechanism? So, mechanism will be the pathway that a reaction has followed for formation of the products. So, in mechanism, what will happen? Concentrated sulfuric acid will form H plus and HSO4 minus. Basically, it is acid, so it will lose the proton. So here it is strong acid, so it is conjugate base of that acid. Remember this. Okay, here sulfuric acid is an acid, and hence the HSO4 minus is the conjugate base of that. Now, what will happen? You are knowing in case of alcohols, there is oxygen atom. This oxygen atom is having the lone pairs of electrons. Now, this lone pairs of electrons, what they will do? They will attack on this H plus. So basically, they will act as the nucleophile. When they will act as the nucleophile, they will form this type of material. So this will form this type of material. Now, this structure is very unstable. Why? Because it has got positive charge on oxygen atom. Remember the nature of oxygen atom. The oxygen atom is electronegative in nature, so positive charge cannot be present on that. So what it will do? It will immediately break the bond with the carbon and get the electrons back. This is your unstable molecule. Now what will do? This bond will get break, oxygen will get its electrons back, and ultimately it will be converted into the cation. Basically a carbocation. Now this carbocation is again unstable. So what will happen? In step number 4, this will be stabilized. So how it will be stabilized? Let us have the look. So now HSO4 minus will come into the picture. So what HSO4 minus will do? HSO4 minus is a base. It will abstract the proton. अब आप बोलोगे इसको नहीं लिया, उसको ही क्यों लिया? ये तो पहले से ही बेचारा इलेक्ट्रॉन का टर्म्स में भिखारी है, तो इसका तो लेने का कोई चांस ही नहीं है. मतलब यहाँ पर this proton will get removed, this bond will come over here. So what will happen? C H H C H. This was the previous thing. Now this bond when shifted to this will result into alkene plus H2SO4 you will get back. So basically you can see that sulfuric acid is acting as the catalyst over here. Why? Because at the end of the reaction it has been regenerated. Okay? It is regenerated at the end of the reaction. Done? So this was the mechanism part. Now let us take some examples. So for examples, let us say that we are taking ethanol. So ethanol when heated with concentrated sulfuric acid at temperature is very important over here, 440 kelvins. So when it is reacted with this alcohol or heated with alcohol at 440 Kelvin temperature, what will happen? With alpha position, OH group will get out. With beta position, the hydrogen will get removed. So basically, this will be forming alkene like this. This will form alkene like this, and the molecule of water will get out. Let us take some more examples also. Let us say we are taking here methanol won't react. That is very clear because methanol cannot form alkene. So when this primary alcohol, again this is primary alcohol, it is not necessary to write the names. You are writing alcohol, that is must and necessary and sufficient also. So when it is reacted with concentrated sulfuric acid at 440 Kelvin temperature, what it will do? OH group from alpha position will get out, hydrogen from beta carbon will get out, and it will form the alkene like this: CH3, CH, double bond, CH2. This is the alkene which is formed by dehydration of the alcohol molecules. Remember that the temperature in this reaction is 440 kelvins. Here the temperature is 440 kelvins. If you change the temperature, over here, what will happen? The product formed will be different. Now let us say that we are taking some more temperature, that is 413 Kelvin. So at that time, what is happening? Let us see. Case number 2. Now the reaction temperature will be 413 Kelvin. Case number 2. Let us say temperature of the reaction is 413 Kelvin. Let us say the temperature of the reaction is 413 Kelvin. So here, in this case, alcohols undergoes dehydration and forms ethers. यहाँ पर इस टेम्परेचर के ऊपर अल्कोहल डिहाइड्रेशन अंडरगो करता है और ईथर बना लेता है, ठीक है, एंड इट फॉर्म्स ethers. Let us see. So here alcohol reacts with, actually two alcohol molecules react with concentrated sulfuric acid. The temperature of the reaction is 413 Kelvin and they will form ROR by removal of water. So basically they are forming ether. Let us understand how this is happening. So basically what will happen? The two alcohol molecules will undergo the dehydration. Now the question is how they are undergoing the dehydration. So two alcohol molecules can be write like this. Now organic chemistry का rule है, when two hydroxyl groups are in vicinity, they are close together, they will automatically remove the water molecule. So what will happen? ROR will form, that is your product, ethanol. Let us take some example. So if you take ethanol, so can we write the ethanol के two molecules like this? This will be reacted with concentrated sulfuric acid. Temperature of the reaction will be 413 Kelvin. So this OH will get combined with H of the neighbor and this will form the ether. CH3, CH2O, CH2, CH3. They will form the ether. Now, what is there in the mechanism? Let us see how the mechanism goes for this case. Remember, this case temperature is 413 Kelvin. So let us have a quick observation about the mechanism. So for mechanism, the first two steps remain the same. In first step, this H2SO4, concentrated H2SO4, which is acidic in nature, will liberate H plus and HSO4 minus, which is basic in nature. Okay? This is conjugate base of this acid, so obviously it is a base. So now what will happen? The molecule of alcohol having oxygen atom, this oxygen atom has the lone pairs of electrons. This lone pairs of electrons will attack on this H plus and this will form the hydronium ion OH plus. This is unstable. Why it is unstable? Because oxygen, which is electronegative in nature, has got the positive charge, which is not possible to have. So basically, this alcohol molecule having 3 valencies of oxygen atom will break this bond. Why to break this bond? To have the electrons back. CH3, CH2 plus H2O. Now the question will arise that why this oxygen has not got the negative charge. It is because, why? Because it was already having the positive charge. So two electrons will come on the oxygen, the negative and the positive gets neutralized. So now step number 4 is different. Have a look. Step 1, 2, 3 were the same as before. Now in step number 4, this carbocation will get attacked by another alcohol molecule like this. This will get attacked by another alcohol molecule and it will form CH3, CH2O. Okay. This O, CH2, CH3 is coming from the other part, O, CH2, CH3, and this H. Again, this oxygen is positively charged. Why? Because it has got 3 valencies. Now, what will happen? The HSO4 minus, which is basic in nature, will get attacked with this. CH3, CH2O, H, CH2, CH3. What will happen? So the bisulfate ion, that is HSO4 minus, which is a base in nature, this will attack over here. Oxygen will get its electrons back and will be forming the ether, that is CH3, CH2, O, CH2, CH3 plus H2SO4. You can see that H2SO4 is regenerated over here and hence it is acting as the catalyst. H2SO4 is regenerated over here and hence it is acting as the catalyst over here. So you can see that ether is formed as a product. Until now what we have learned? We have learned okay, dehydration of alcohol is a very special reaction. It forms different products at different temperatures. If the temperature is 440 Kelvin, the product is alkene. If the temperature is 413 Kelvin, the product is ether. Why? Because the mechanisms are somewhat different at two different temperatures. Let us have some examples. Okay, I will do one example for you. Rest you will be doing by yourself. चलो, तो the example is CH3 CH CH3 OH plus concentrated sulfuric acid. You are supposed to form the products at two different temperatures. The first is 440 Kelvin, the other is 413 Kelvin. At 440 Kelvin, what will happen? OH from this alpha and beta will get removed. That is CH3 CH double bond CH2. So alkene will be formed. How? So the OH group at alpha will go, hydrogen from beta will go, and it will form alkene along with the removal of water. At 413 Kelvin, what will happen? So two alcohol molecules will get combined like this. Can we write like this? So what will happen? They will form the molecules of water like this. So basically they will be forming the ethers. CH3, CH, CH3O, CH, CH3, CH3. This is basically your ether. So at two different temperatures you are getting the two different products. I'm giving one example for you that you are supposed to do in your copies by yourself. You are reacting this with concentrated sulfuric acid. You have got two different temperatures. The first temperature is 440 Kelvin and the other temperature is 430 Kelvin. At two different temperatures you will be reacting your alcohol molecules and you will tell the products. Obviously you will do this in your notebooks. So for this lecture we are ending up the session. Rest of the content will be delivered in next lecture. Thank you.